Hi guys. We're going to talk about section 4.3, but real quick, I'm going to talk to you about this idea called synthetic division. So yesterday or the day before, you did long division, and polynomial long division is necessary to learn, but it kind of stinks. Takes a lot of space. There's lots of places to make sign mistakes and whatnot. It is necessary though because it always works. Now today we're going to talk about something called synthetic division. And the word synthetic kind of means fake. If you think about like synthetic fabrics and stuff, well, synthetic division doesn't always work, but it works a good amount of time. You can only use it if you're dividing by something like this: x minus 4 or x plus 7 or x minus 20. It has to be a binomial, two pieces, linear, and then just a x and then a number plus or minus. Okay, so that's what we're going to be doing today, and then we're going to talk about some things that work out with that. So the first problem I'm going to give you to practice is this: x to the fourth minus 29 x squared minus 22x minus 7, and we're going to divide it by x plus 5. Okay, so here's how the steps work. The first thing you're going to do is you're going to take this guy that you're dividing by, and you're not going to put 5 in the box. And this is the part people are going to mess up. This may or may not be a factor, but if it was a factor, we're going to put what the 0 would be in the box. So if this was a factor, -5, you would have to change the sign, would be the 0, and you're going to put that in a box, just like a little L-shaped thing. And then beside that, you'll put the coefficients beside the box. And you will have to put in 0 if any terms are missing. So here are all my coefficients. There's a 1 for the x to the fourth. There's not an x to the third, so I'm going to have to put a 0 in there. Keeping the signs, x squared is -29, x is -22, and the number is just -7. So double check to make sure we have everything: x to the fourth, x to the third, x squared, x, and a number. Okay, the next thing you're going to do is you're going to skip a line and then draw a line, and you're going to drop the first number. So you skip a line and draw a line, and the first number we're going to drop is a 1. And then everything is the same. I call it have a party because this is so much better than long division. I call these problems the party problems. So we're going to have a party. And what are we going to do at this party? Well, we're going to multiply and we're going to add. You're going to multiply and you're going to add. And you're going to keep doing that until the party's over. You'll know when the party's over because there'll be nothing left to do. So what do you think we should multiply? Well, I have this 1 here, and this number in the box is just screaming, use me. So you multiply 1 times -5, and you put it right here. Then you add -5. Multiply 25, add -4. Multiply 20, add -2. Multiply 10, add is 3. Party's over. There's nothing left to do. After that, you are actually done. It doesn't feel like you're done. What do you do with all this? Well, the last number is your remainder. So this was not a factor. It did not give me a remainder of 0. The last number is the remainder. And then you have number x, x squared, x cubed, and so on. So this will be the number x, x squared, and x cubed. So my answer is x to the third minus 5x squared minus 4x minus 2. And then the remainder is 3. So you could put like plus 3 over, what did we divide by? X plus 5. So this is called synthetic division. And it is way easier and faster than long division, but it doesn't always work. It only works if you're dividing by those special things. So you're going to do one more of these and see how you do. Pause it once you get it written down here. X to the fifth plus 3x to the fourth minus 25x squared plus 6x minus 4, and you're going to divide it by x minus 2. Okay? So you can pause it and try it on your own. Remember to put the 0 in the box and then the coefficients. Okay, so here we go. We're going to put the 2 in the box. Why a 2? Because you have to change the sign. Coefficients beside it, Make sure you put a 0 if you need to. X to the 5th, x to the 4th. There's no x to the 3rd, so it gets a 0. X squared, x, and then the number. Skip a line, draw a line, and drop the first number. Then you have your party. You multiply, you add. You multiply, you add. You multiplied, 10 times 2 is 20. You add is -5. You multiply, it's -10. You add is -4. You multiply, it's -8. And the remainder here is -12. So it's your remainder, your number, your x squared, x to the 3rd, and x to the 4th. And you could write it out, x to the 4th plus 5x to the 3rd plus 10x squared minus 5x minus 4. And you can put a remainder -12 if you want as well. Okay, so that's how you do synthetic division. And now we're going to look at our notes. So we're going to use synthetic division to help us a little bit today. And we're going to learn a couple little theorems here. One's called the remainder theorem and one's called the factor theorem. And I think you're going to think these are, they should make sense to you. Okay, so first thing, when you divide, let's see here. When you divide, remember that you're looking to know if something is a factor or not. If it's a factor, the remainder is 0. If the remainder is 0, then it's a factor. Why is it a factor? Well, because it would be an x-intercept. So they are giving us this polynomial. It's a cubic polynomial. And remember, a couple weeks ago, I said, we don't know how to factor it. But now, if we use division, and you can find one of the zeros, then you can divide it out and factor what's left, because you do know how to factor x squareds. So they want to know if x plus 1 or x minus 3 is a factor. So that's just basically asking me, hey, is the remainder equal 0? So there's a couple ways you can do it. The first way will be the synthetic division. If this is the factor, what would be the 0? I would put -1 in the box. Put the coefficients 1, 2, -5, and -6. And then have the party. Drop the 1 and multiply. -1, add. Multiply, -1, add. Multiply, +6, add, and you get 0. So the remainder is 0, the number, x, and x squared. So what I actually get here is x squared plus x minus 6. And that means, since it is a factor, if I take this guy times that x plus 1 that I divided by, that equals what I started with. So I actually factored it a little bit. I got x plus 1. Well, this should be good for me because I know how to factor this. If I make a list for -6, 1 and -6 works, but doesn't give me the 1 I need. 2 and -3 gives me -1. So -2 and +3 would give me +1. So this factors to x minus 2 times x plus 3. And then you have your x plus 1. And now, all of a sudden, by just knowing one of the factors, I was able to completely factor this guy when I used to not be able to know how. Now, they ask if x minus 3 is a factor. I already know x minus 3 is not a factor because I have already factored it. But if you wanted to check, you could put 3 in the box and you would repeat the process. 1, 2, -5, and -6. Skip a line, draw a line, and have your party. 1 times 3 is 3. Add is 5. 15. Add is 10. 30. The remainder is 24. So it's definitely not a factor because it's only a factor if the remainder is 0. So that's the first thing. We can use division to help us find factors. And that's the one we just did. They're talking about it again, and we said the remainder is 24. Okay, so here's the first thing that we can talk about is writing it. So I wrote down on the last one, what was it? Let's see if I can back up in time here. Go back in time. There it is. I wrote out that x minus 2 times x plus 3 times x plus 1 equals that big guy that we had. Let's see what it was. Let's erase this. And go up a few slides to see what it was. There it is. X cubed plus 2x squared minus 5x minus 6. Okay, so we said that this equals this. Well, there was one that didn't work though. X minus 3 did not work. So this slide here is saying if you get a remainder, you can still write it out like this, but you have to put the remainder as an adjustment. So we were trying x minus 3. And remember, for x minus 3, you had to put the 3 in the box. And I'm going to write this down again. 1, 2, negative 5, negative 6. And I get 3, 5, 15, and 10, 30, and 24. So the remainder is 24. The number is 10. The x is 5, and the x squared is 1. So what we can do here, and this is what they're saying, you're going to have to do it on your homework. You can write, what did we divide by? X minus 3, which didn't work out. What did it leave us with? It left us with x squared plus 5x plus 10. So you close those two parentheses. And then after end of the parentheses, then you could put plus the remainder. It's like your little adjustment. If I double distribute this and add 24 at the end, I will get what I started with. Now, that's a little bit different than the way we wrote the fraction. You could have done that as well. You could have said plus 3, x minus 3 times x squared plus 5x plus 10 plus 24 over x minus 3. And you could have done two parentheses like that. This one, you would have to like quadruple distribute. You take the x to everybody in this, and all those fractions would cancel out, and you would get the same thing. So you could write it like this, which is kind of ugly, or you can write it like this, which is a little nicer, but you have to remember to put that adjustment at the end, just like you do whenever you complete the square. Okay, so next thing is the remainder theorem. And what the remainder theorem says is if a number is a 0, when you plug it into equation, it equals 0. And that's duh, because it's an x-intercept. If a number is not a 0, when you plug it in, that number will be what the remainder would be if you divide it. Okay, so we're going to go back to those two problems we just looked at. One of them had a remainder of 0, and one of them had a remainder of 24. So let's go back here. X plus 1. What would the 0 be? The 0 would be negative 1. And if you plug that in, look what happens. Negative 1 to the third plus 2 times negative 1 squared minus 5 times negative 1 minus 6. So that's negative 1. This will be plus 2 plus 5 minus 6. What does that equal? It equals 0. So we know that negative 1 is a 0. So this gives us a second option. The first thing you could do to check if it's a 0 is you could divide and see if the remainder is 0. The second thing you could do to check to see if it's a 0 is you could just plug it in and see if it equals 0. Why would you want to do one over the other? Well, when you plug it in, a lot of times you will have to use a calculator. When I do synthetic division, a lot of times I don't. So that might depend. There's a third way you could do it as well. You could graph it and you could look at the table. So those are the three ways you could check to see if something is a 0. So how about the one that wasn't a 0? X minus 3. X minus 3 was not a 0. That means that 3 was what we need to see if a 0. 3 was not a 0. But how could I tell by plugging it in? Well, take a look. 3 to the third plus 2 times 3 squared minus 5 times 3 minus 6. 3 times 3 is 9 times 3 is 27 plus 3 times 3 is 9 times 2 is 18 minus 15 minus 6. Well, what does that give you? Well, if you add those up, you get 24. The remainder theorem said whatever number you get would have been the remainder if you divided. So now I know that if I take x minus 3 times whatever I would have gotten from division, the remainder would have been 24. There would be 24 left over. Okay, almost done. Last thing we're going to talk about here is, okay, we're going to try this last one here. They want us to factor this guy that we aren't used to factoring. Okay, so there's three ways you can do it. Number one, we could use division. Number two, you could start plugging in things to see if you can get 0. And number three would be to use your calculator. And on this one, the best thing to do will be to use your calculator because they didn't even give us something to try. If you use your calculator and you type in the equation into y equals x to the third minus 3x squared minus 6x minus plus 8, I'm typing it in right now, x to the third minus 3x squared minus 6x plus 8, and I go to my table, here's what I see. I see negative 3 is negative 28, negative 2 is 0, negative 1 is 10, 0 is 8, 1 is 0, 2 is negative 8, okay? So how many zeros am I looking for? Well, I'm looking for 3. I found 2. Here's 1 and here's the other. I need to keep scrolling to see if I can find another one. And if I go down a little bit further, I'm kind of running out of space, but 4 is the last one. So once you find 3 from your calculator, I didn't even have to divide it all. I could say, okay, I know all 3 zeros. Now I can write them as factors by changing the sign. And this is the same thing as that. If I wanted to solve it, I could solve it by setting each factor equal to 0, and it'll be negative 2, 1, and 4. Those are the solutions, or the zeros. And these guys are the factors. So you can use your calculator as well. So if they tell you one, you might use division or plug it in. And the last thing you could do is use your calculator. Okay, so you can start the 4-3 homework and see how well you do.